Hello all. Let us take up this topic, analysis of series, parallel and series parallel circuit. First let us see what do you mean by series circuit. Two or more elements are said to be connected in series if same current flows through them. So let us consider the resistive circuit given below. Here V is the applied voltage, I is the resulting current, R1, R2, R3 are the three resistances which are connected in series. V1, V2, V3 are the voltage drop across each resistances. So the total voltage V is equal to V1 plus V2 plus V3. According to Ohm's law, we know that V is equal to I into R. Therefore, IR is equal to IR1 plus IR2 plus IR3. Common as current I outside. So, IR equal to I into R1 plus R2 plus R3. Therefore, resistance R is equal to R1 plus R2 plus R3. In case of series connected resistors, the equivalent resistance R is equal to the sum of individual resistances R1 plus R2 plus R3. So, we can say in series circuit the equivalent resistance of a number of resistances connected in series is equal to the sum of individual resistances. In summary, in any series circuits, all components share the same current. Sum of the voltage drop across each element is equal to the total voltage applied. Total resistance is equal to the sum of individual resistance. This is about the series circuit. Now let us see the parallel circuit. Before that, let us see the example. Find the current flowing through given circuit. Simple circuit is given here. 9 volt is the applied voltage. Resistance R1, R2 and R3 are connected in series here. 3 ohm, 10 ohm and 5 kilo ohm. So 3 kilo ohm, 10 kilo ohm and 5 kilo ohm which are connected in series, total resistance will be 18 kilo ohm. The current flowing through which is according to Ohm's law I is equal to V by R, that is 9 by 18 kilo ohm will give you 0.5 milliamperes. Now let us see what is parallel circuit. Two or more elements are said to be connected in parallel if same voltage exists across them. Let us consider the resistive circuit shown below. Here R1, R2 and R3 are three resistances which are connected in parallel across voltage source having voltage of V. Current flowing through each resistances are I1, I2 and I3. And now we see I1 equal to V by R1, I2 equal to V by R2, I3 is equal to V by R3. Total current flowing through the circuit I is equal to I1 plus I2 plus I3, that is according to Ohm's law I is equal to V by R. So, V by R is equal to V by R1 plus V by R2 plus V by R3, that is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The reciprocal of equivalent resistance of a number of resistances connected in parallel is equal to the sum of the reciprocals of the individual resistances. In summary, in any parallel circuit, all components share the same voltage, branch currents add to equal to total current, resistances diminish to equal to total resistance. So, let us note, if two resistances say R1 and R2 which are connected in parallel, then its effective resistance is given by Rp is equal to R1 into R2 divided by R1 plus R2. This is given for the solving the problem. This will help you to solve the problem in simpler manner. Let us take the example. Find the current supplied by the source. Here two resistances 250 ohm and 350 ohm which are connected in parallel across 20 volt resistor, 20 volt battery source. Total resistance of the parallel combination Rp will be R1 into R2 divided by R1 plus R2. That will be 250 into 350 divided by 250 plus 350, that is equal to 145.83 ohm. Therefore, current is equal to V by R, 20 volt divided by 145.83 ohms will give you 0.1371 amperes. Now, let us take up series parallel circuit. Here, let us directly take a problem. We can see there are two branches here, 100 ohm and 250 ohm first branch, 350 ohm and 200 ohm are the second branch. These two branches are parallel combinations. How to solve this, which is connected across 20 volt? How to solve this? First, individual parallel branches are reduced. Then you can able to get, here you can able to see individual branches. When you reduce it, the effective resistances you are going to get 71.429 ohm and 127.27 ohm. Those two are connected in series. Therefore, we can add together, we will get 198.70 ohms. Now, the current I is equal to 24 divided by 198.7 is equal to 0.1207 amperes. Now, this is the answer which we get. These are the references. Thank you.